Swayam Prabha. Digital India. Educated India.
Good afternoon, everyone. In 2 minutes, we'll start presentation of Professor Wu. This is the session on modeling and simulation. And there are 4 talks. Each talks, we have a total 20 minutes. So I suggest that 15 to 17 minutes of a presentation and have some interactions for 3 to 5 minutes. In 1 minute, we'll start with Professor Wu.
Thank you, Chair. My name is Wei Wu, separate the NCKU in Taiwan. Today, my topic is the focus on the machine learning for the natural power system, and we try to produce that the pollutants include that the CO and the NOx. Okay, this is all the process. This is the power system. So we can from this picture. So total is the 9 variable input variable, and the 2 output variable include that the CO and the NOx. So in this process is that we can do it from the Aspen and some of the data from the website. So based on this the data set, we try to figure out what's data in here and try to modeling and do some the prediction. This is our purpose. So in this study, is based on the past the studies. So many the scholar focus on the machine learning algorithm, but in my recent research, we focus on how to improve that the machine learning algorithm. Here is our flow chart. So in this flow chart, we propose the 2 approach. This is a kind of combination, include the feature selection and hyperparameter optimization here. So we follow this the flow chart. We can try to improve the machine learning algorithm. Okay, so based on this the data. So the data total over the maybe the 100,000 the data from the website. So that data just showed here in this page. So we can find the data, the patterns that include the output, the 2. You can see that the pattern is a big different from the CO and the NOx. And here, the total is 9 input variable that the data pattern improved here. So based on this, over the 100,000 data, so we try to figure out how to build out the machine learning model. So before the machine learning model, so the first step, we need to do that the feature selection. So this feature selection just we use that the Python to that include some the function. First is the Spearman the rank correction coefficient. Based on this the coefficient, we can do that the check that the ranking of the relevant features. Okay, so another the index is the mean absolute error. We call that MAE, and another one is MSE. Try to indicate that the training performance. Okay, follow that the feature selection for CO emission, so we can find this the result. So we can find this the factor, follow this the ranking, so we can see that the first, the higher that means the important, the lower that means not important. So based on this the figure result, so we can find total is the 4 input variables are important. That means for example, this I give the explanation. AT means the atmosphere, the temperature, and the GDP, that is the combustion. Sorry, I forgot that I need to go back to check that this the abbreviation. So CDP, that means the compressor, the discharge pressure. That means follow that the four variables, so we can make decision that needs the four, the input variable dominant is the compression, the efficiency. So that go to outside that the flue gas will going to use the gas turbine to produce the electricity and emit that the flue gas. So we can find this the four input variables important. Even we use that the Aspen simulation, we can find this the similar result. Okay, then this figure just show that how to find this the total that the variable, because to make sure that is important. Here is just the step by step to make sure which one that's the collection is to guarantee the MAE is lower. Okay, in this line we shows another the feature selection for NOx emission. So we can find here is the AT and the AP is also important here. So we can find it's not difference, big difference to that the CO. So we, in my experience and my student experience, for this case, it's not easy because we can find that the important that the result, only the AT becomes the one important. But other variable we tried many times is still very low. So based on this the information, so we can find that the MAE still very large. So you want to find a low that the MAE is not easy in this case. So that means that for that the CO emissions, we not the selection the four input variable is more feasible. Okay, after that the feature selection, we move to that the machine learning model. So in our study, we select the four machine learning model. Here is the deep neural network, we call the DNN. And the right side way is the low short-term memory network is here. And the third one is the random forest. And finally is the, we call the SG boost. So based on this for the machine learning model, we can still a big difference. And the previous that the deep neural network model and the LSTM model is similar based on the network the configuration. And here is the random forest and the SG boost based on the classifier. Okay, so move to here, we can find that make a comparison between that the DNN and the LSTM and just like sorry, long short-term memory in the network. So we can find that in this figure to find after several the iteration, for example that in the left side the training loss going to that the lower, that means the conversion, and also the validation loss is also very low in this figure. And the right side is for that the long short-term memory network, we can find a similar result, but the training loss is still the higher compared to that the validation loss. But anyway, this result just tell us the conversion is okay. And another slide just for the emission. Sorry, the previous for CO and here's for the NOx. So we can find based on the DNN and the short-term that the memory. So we can find this the error is the higher than the previous slide. So we try to improve that the error. So we try to use that the hyperparameter optimization, try to improve the accuracy, the prediction accuracy for that the DNN and the long short-term memory network. So what is the hyperparameter optimization? That means we try to change that, for example, right side, we just change that the hidden layer, the number in here. And also the right side, we also similar like try to change that the network number, that means the new neural number. So follow this the figure, we try to find out which the good combination to guarantee that the minimal MAE and the right size also. So based on this figure, we can determine the best configuration. And here also to prove that the NOx emission by using that hyperparameter optimization tool. So we can find that even use that DNN and the other LSTM. So we can also find the minima the MAE based on the different selection. And this slide just to show that another type the hyperparameter optimization for the random forest and the SG boost. So different the previous that the DNN and the shortened that memory the network. So here we just to choose the several the parameter from this slide. So we can simulate the previous to reduce that the parameter. So you can see the MAE, for example, that the mass depth, that the color to make sure that the MAE is lower. These figures for CO emission, and the next figure here is for the NOx emission. So based on the list selection, we can find the optimal the parameter. That means the hyperparameter optimization in this algorithm. Okay. So finally, we just make a comparison. This is a very important result. So based on the list two figure, we can to get some important information. For example, the left side, this is the CO emission. We can make a comparison. For example, based on the for the machine learning the algorithm, we propose that the MOS, that means this approach can improve the prediction accuracy. So that means for example, this color going down for the DNN, that means we use the MOS. And for DNA is better than that LSTM. But in the forest, random forest, that improves very large compared to that the LSTM and the DNN. And the SG boost is going down a little bit, But based on this CO emission comparison, so we can find the random forest that was improved by our proposal the MOS. So we can see even based on here design, here is the comparison. So we can find the random forest is better than the traditional the neural network. And the right side, that is improved, just not good. So because the previous I just tell you, because that the data may be some the problem. So we can find that the improved just very little. But anyway, the DNN still show that the spatial that the good result compared to that the other the machine learning model. But anyway, the random forest and the SG boost is still similar like the performance similar to that LSTM. And this is the final result. Now make a conclusion. Based on the four machine learning the algorithm, we can find that we propose the figure optimization scheme, FOS, and can give that good efficiency, improve that the machine learning model based on this demonstration. Okay, thank you very much. Any question?
Are there any questions from the audience? we'll take first questions from audience in person, and then if there are questions from online, we can ask them. Okay, thank you.
Hello, Wei. This is David from NTHU. Yeah. So how do you do your features election? Is it based on a linear model or something else? So you do a feature selection first and then you do modeling. But was your feature selection based on linear models or just correlation analysis?
Just correlation.
Thank you.
Just correlation. Sorry. Yeah, in my experience, like our previous study only based on this the data, but in the training, in my experience, the DNN and the LSTM, in the training procedure, take a lot of time. So that means the neural network, that means it can good to feed the model because neural network is a good behavior for nonlinear model. But the question is that spend a lot of time to do that training and the validation. So you can see that the accuracy is better than the other. But in our study, we try to use that FOS to try to improve that the accuracy. Even we use that random forest and SG boost. So we can find just a few results. If we use that MOS, we can try to improve that accuracy for this case, only for this case. And this is my recent result. Just okay.
Yeah, thank you for your presentation. I'm Shota Kato from Kyoto University. And you used only the nonlinear regression method, but did you use the linear regression method?
I'm sorry?
Did you use any linear regression method? For example, PCR or the PRS?
I'm not sure. In this case, I'm not sure.
Okay, thank you.
Yeah, I'm sorry.
There is one, I think, question online. Can you look at it, or we'll you have to click on that. So there is a question. Can you please comment on the uncertainty quantification of the models? And do you have some 95% confidence interval or standard deviation on the model predictions? That's the question in online. Can you like to comment on that?
No, not yet.
Okay.
Because the data only from the website, but this data still not consider more the detail. So we try to do the future work.
Okay. Okay. Thank you. I think we have time for one more question. I have one clarification, if I can ask. So you have built a different model for CA and NOx. Am I right? Separate model for predicting CO and NOx. Have you tried to build together any models and try to see how the performance is, like multivariate models?
Yeah, I'm sorry, because this is not only from the real plan. So we try to, in this the current study, we try to do that modeling, because the data from the website. So our current study just make a comparison between that the four machine learning model. So in this the current study, just study which model of machine learning is okay or not okay for this case. So in the future, if this model is okay, I want to apply for consider more the constraint or uncertain in this case.
Okay, yeah, thank you. Thank you, Professor Wu, for your presentation.
Thank you everyone.
Thank you very much.